In this lesson, we're going to discuss discrete statistical data. Given a set of data, for example, here representing the scores of students on an IB exam out of 7. This set is the set of raw data, where raw data is the set of data collected, which usually would be too big and unorganized, making it impossible to draw information from. This is where we make use of frequency tables. The first column for the test scores, including the variable values, which in this case is a discrete variable as it takes specific numerical values and is not measured. And the second column, including the frequency of each score, which is the number of times each value occurred in the data set. For example, we can find a score of 2 7 times in the set. Then score 2 has a frequency of 7. 3 occurred 8 times in the set, so 3 has a frequency of 8, and so on. And at the end, the total frequencies of 30 should be the number of elements we have in the data set. Then this is what we call a table of frequency, which we use to organize our set of raw data. Now, having organized our data set in a frequency table, we need to see how we can present our data. A first way is using a bar graph. Drawing a set of two axes where the horizontal axis corresponds to the scores on the IB exam and the vertical axis corresponds to the frequency of each score. I add a scale to the axes, noting that scales on both axes could be different, but both should be taken to a scale. Then from each score, we draw a bar up to its corresponding frequency. Now, using the frequency, I can also draw the frequency line graph, which is done by considering the scores and their frequency as an ordered pair, x for the score and y for the frequency. Then plot these points and then connect them using line segments, keeping in mind a frequency of 0 for scores 1 and 4. Now, another type of line graph we can draw is an increasing line graph, where for this one, we must add a column to our frequency table to begin with, titled cumulative frequency. To calculate the cumulative frequency, we need to first make sure that the data listed in our table are in increasing order. Then I start by taking the first frequency and add it to the next one. Repeat the process throughout, and the last cumulative frequency obtained should be our total frequencies. And again, we plot the points, taking the scores for x, but this time the cumulative frequency for y. And for that, I change the y-axis to take the cumulative frequency, adjust its scale to accommodate for the y values I need, and then plot the points. And again, connect them with the line segments. Cumulative frequencies and increasing line graphs are very useful, as for example, the cumulative frequency of a score 3 tells me there are 15 people that scored 3 or less, or 10 people that scored between 5 and 7. By subtracting their cumulative frequencies instead of adding the frequencies one at a time, which is not practical for big data sets. Now we have the last graphical representation, which is a pie chart, for which we need the angle of the sector of the circle corresponding to each score. And for that, I take the frequency of the score divided by the total to find the proportion of each score from the total, and then multiply by 360. For example, a score of 2 has a frequency of 7. Then I divide 7 by 30 and multiply by 360 to obtain 84 degrees. Similarly for the rest. Now the total angle should be 360 degrees. Now I draw a full circle where I use the angles calculated to allocate a sector for each score. Now let's summarize. We've seen that to organize a data collected, we use a frequency table. Then to present the data collected, we use for discrete data a bar graph, a frequency line graph, an increasing line graph, or a pie chart. Now in our next lesson, we are going to look at calculating central values, and measures of dispersion for interpreting our data collected.